Okay, so let's scoot on. Let's talk about graphing a parabola. Now, here's the equation that we're going to graph. F of x equals x squared. Remember, f of x is another way of saying y, so this is y equals x squared. So, let's go ahead and make ourselves a table. And we're plugging in x's, seeing what's coming out for y or f of x. It's the same thing, remember. So, I have favorite numbers that I like to plug in, as long as they don't give me funky little fractions. I like a positive 2 and a positive 1, 0 obviously, but then I'd like some negative numbers at the same time, because I need to know what's happening in the negative end of the world. So, I'm not going to insult your intelligence. You plug in 2 for x, you're going to get, right, 4. You plug in 1, you're going to get 1. 0 gives you 0. Negative 1 to the power of 2 is still a positive 1. And negative 2 to the power of 2 is still going to give you a positive 4. Agreed? Now, here's the deal. When we graph this, and I'm going to put our graph over here, we have these 5 points. We have 0, 0, clearly. We have 1, 1, and we also have negative 1, 1. We have 2, 4, and negative 2, 4. And when we connect our dots, we get this wonderful looking parabola. Shape of a U. We call it a parabola. Good? Okay, so there's a few items here that we can identify. So one of the items that I'd like us to identify would be the domain of this parabola. Now remember, domain refers to your x's when you are graphing. So the domain, if I look at this parabola, on my board here it stops because I'm running out of room. But if I look over here in the negative end of the world, my parabola doesn't go just straight up, it goes up and out, doesn't it? So it keeps going this way. So it keeps going towards negative infinity, doesn't it? And on this end of the world, it doesn't go straight up, it goes up and out. So it keeps going to positive infinity, doesn't it? So your domain is a negative infinity to a positive infinity. Good? Okay, now let's look at the range. The range refers, when you are graphing, to your y values. So if you come up from the bottom, because remember, you always go from the smallest numbers to the largest numbers, my graph doesn't appear until y is equal to 0. And it keeps going up, doesn't it? Without any end. Agreed? So my range will go from 0 to infinity. And yes, we put a bracket on the 0 because we actually have a solid dot there. You with me? Okay. One last piece of information to identify is this thing called the vertex. Now, the vertex is where the turn of the parabola is. So this parabola turns at 0, 0. So my vertex would be considered 0, 0. Good? Are you guys with me? Okay. Now, this is what I call the parent graph. There's nothing added onto this x, nothing subtracted from it, nothing multiplied to it, absolutely nothing. So, I'd like you to take a look at these two equations, these two functions I'm going to write, these two equations I'm going to write, and then I have a question for you. Now, if you notice, both of these functions that I have written have a plus 2 attached to them, don't they? This one has the plus 2, and this also has a plus 2, doesn't it? But there's a difference where I put the plus 2, isn't there? On this particular function, the plus 2 is after the x squared. On this function, the plus 2 is actually inside with the x, isn't it? Okay, so here's how I like to phrase things. One of these functions has that plus 2 invading the space of x. It invades the space. The house of x opened their doors and in moved the positive 2, or the plus 2 I should say. This one is where the house of X opened its doors, because now I've got these parentheses, and the plus 2 moved inside. Notice the square is outside, isn't it? This one, when you have a number that's inside the parentheses of the X, this one affects the X's, which means your graph is affected either left or right. This graph, or this function I should say, notice the plus 2 is outside the X squared. Since it's outside the X squared, it's not affecting X, which means in this case, it's going to affect your Y value. And Y's go up and Y's go down. Are you with me? Okay, so hang in there. We're going to talk about some graphs where we start putting numbers in and seeing what happens to our parent graph. I'll be right back. Okay, so let's look at an example. Let's bring that function back where we had x squared plus 2. So, help me out a second. This 2, is it invading the space of x? No, it's not. It's outside the x squared, which means it's not affecting your x's, it's affecting your, good, this is affecting the y values, okay? Which means if I go back to the parent graph over here, where I plugged in all these numbers, here's what we know. We plug in 2, we get 4, don't we? But then over here, after you get 4, what are you supposed to do? Yeah, you're supposed to add 2, aren't you? Which means I'm going to get new y values. And when I add that 2, I'm going to get a 6. Over here on the parent graph, you plug in 1, you get 1, don't you? But over here, after you get the 1, you're supposed to add 2, which means you get, good, 3. Over here, you plug in 0, you get 0, don't you? But over here it says after you get the 0, you add 2, which will give you 2. Are you with me? You get the hang of what I'm saying? So, plugged in -1, you get 1. But then over here it says to add 2, which means you get 3. And lastly, you plug in -2, you get 4. But then over here, after you get the 4, you get, right, 6. You with me on this? So take a look. Here's the graph for x squared. And now, these were my original y values. Notice the x's have not changed. What's changed for this first problem is the y values. All the x's have stayed the same. It's the y values that have changed. So, instead of the 0.24, I'm going to plot 2, 6. That's right. So here was 2, 4, and now there's 2, 6. Plugging in 1, 1 was right here, right? But instead of the 0.11, I have the 0.13 for this graph. So here's 1 and 3. Instead of 0, 0, I'm now plotting the 0.02. Instead of -1, 1, I'm now plotting -1, 3. And lastly, the point -2 and 6. So here's the deal. Here's my new graph for number 1. So question. By adding this plus 2, what did that do to the original parent graph, the one in blue? We added 2 at the end, which affected the y's. What happened to this graph? Awesome. This graph went up 2 spaces, didn't it? So question, is your vertex still at 0, 0? No, the vertex is now at 0, 2 because it went up 2 spaces. The y value was affected. Are you with me? Domain. The domain for the parent graph is -infinity to +infinity. Now let me ask you something. If this plus 2 affected the y's, remember, the domain when you're graphing deals with which variable? That's right, it deals with the x's. Since this plus 2 affected your y's, is the domain going to change? Excellent. It will not, because it affected your y's, not your x's. Lastly, the range. When you're graphing, the range affects which variable? That's right, the y's. The range refers to the y's, I should say. So, in this particular case, this plus 2 shifted the graph 2 spaces up, didn't it? It affected the y's. It went 2 spaces up, didn't it? So is your range still going to start at 0 and go to infinity? Excellent. It's not starting at 0 any longer. It's starting at 2, isn't it? Okay. Whoops. How about I fix that 0 and make it a 2? So it's starting at 2 and it's still going up until infinity. Are you with me on this? Cool. So adding this 2 at the end affected the y's, which means your vertex shifted up 2, your range shifted up 2, the entire graph shifted up 2 spaces, because the difference from the old y's to the new y's was 2 spaces up. Does that make sense? Okay, let's look at another problem. And now we're going to deal with the function where x squared minus 3. Okay, so help me out. This minus 3, is it affecting the x's or the y's? Excellent. It's affecting the y's because it's outside of x squared, so it's affecting your y values. So since it's affecting your y values, over here, what's going to change? The x's or the y's? Excellent. The y's are going to change. So we are going to have new y values, aren't we? So let me get rid of these guys from problem number 1. So for problem number 2, what's happening to every single y value? Hopefully some of you said you're going to minus 3 from each one of them. Some of you may not be sure, so let's look. On the original graph, you plug in 2 to x squared, you get 4. Over here, after you get 4, you're supposed to do what? Minus the 3. So I guess you are subtracting 3 from each of these y values, aren't you? So this is telling you this graph is going to go down 3 spaces, isn't it? So, plugged in 1, you get 1. And then over here, after you get 1, you're supposed to minus 3. Plugged in 0, you get 0, but over here it says minus 3 from that. And the same with the rest of these, right? Okay, so take a look. Your graph in blue is the parent graph. And now my new y's have taken my graph down 3 spaces, hasn't it? Which means we're not at 0, 0 any longer. We're at 0, negative 3. And negative 1 with negative 2, positive 1 with negative 2, 2 and positive 1, and there. Okay, so if I connect my dots, the one in orange is my new graph. It did go down 3 spaces, didn't it? So help me out. The parent graph says the vertex is at 0, 0. Is it still at 0, 0? No, the y's were affected. This y value is going to change, which means your vertex is now at 0, negative 3, isn't it? The domain. The domain refers to which variable? Good, your x's. So does the domain change? Nope. Domain stays the same, negative infinity to positive infinity. And your range. The range is the y's, isn't it? So does your range still start at 0? Not in this case, because in this case it went down 3 spaces. So in this case your range actually starts at negative 3 and goes to infinity. Cool? Okay, so this is what the information looks like when the number added on is outside of the x's and it's affecting your y's. Your graph is either going to shift up or it's going to shift down. And the vertex and the range are changing on us. Cool? Okay, hang in there. I got some that are going to affect our x's. Okay, so let's look at this next example. Now, in this particular case, there's that plus 2 again, correct? But do you notice the plus 2 has moved inside the house of x? The house of x opened its doors the parentheses, in moved the plus 2, and it has stayed. Notice the square is outside, which means in this particular case, this plus 2 is affecting our x's, which means x's go which direction again? Left or right, and we've got to figure it out. So my y values stay the same. Now I have new x's that I've got to find. So again, this is the information from the parent graph, just x squared. Here is the parent graph. Here is the vertex, the domain, and the range of the parent graph. And we've got to see what this plus 2 is going to do to this information. Got it? Okay, so let's take a look. So I need to find new x values. So just watch, hear my questions, and let's see what new x values I need. I'm going to start with this 0 because that's the easiest number to work with. I know when I plug in 0, I get 0. Yes? Okay, I need to find a new x that when I plug it into x plus 2, it gives me 0. So what number plus 2 will give me the original x of 0? Good. If you said -2, that's correct, because -2 plus 2 is that 0, isn't it? And then when I square it, I get 0 for the y's, don't I? The squaring comes last now, doesn't it? I have to do inside the parentheses first, because that's the order of operations, and then I do the squaring second, don't I? Okay, let's look at another one. Let's look at this +1. I know when x was +1 and I squared it, I got 1, right? Okay, so what number can I plug in for this x that when I add it to 2 will still give me this original +1 for the x value? If you said -1, you're right, because -1 plus this 2 gives me this original +1. And I know when I square 1, I get 1, right? Okay, think again now. Let's look here. What number, what's my new x that when I plug it in and add 2, I get the original number of 2? Excellent. If you said 0, that's right. That's correct. Because 0 plus 2 gives me this original x of 2. And 2 to the second power I know is 4. Good? Okay, so notice, all of these new x values are to which side of the old ones? Yeah, this 0 is to the left of the original x. This -1 is to the left of the original +1. This -2 has a value that's to the left of 0. And these are all left by how much? Good. They're all left by 2 spaces. So let's look here. Let's make sure it worked. What can I plug in for x that when I add 2 will give me -1? Good. -3. Because -3 plus 2 is -1. And when I square -1, I get +1, don't I? Lastly, if I plug in -4 and add 2, I get -2, don't I? And when I square it, I get that +4. Agreed? Okay, all of these x values are to the left of the original x values by 2 spaces, which means my graph is getting picked up and moving left 2 spaces. So watch. I'm now at 0, 4. Because remember, new x's and the original y's stayed the same because this wasn't moving the y's, this was only affecting the x's. So now I'm at 0, 4. Correct? Okay, so there's 0, 4. Now I'm at -1, +1. There's that. Now I'm at -2, 0, and here we are there. Now I'm at -3, 1, which means I'm here, and -4, 4, which means we're up here. So this graph picked up and moved 2 spaces to the left, didn't it? So let's look what happened to the vertex, the domain and the range. Okay, the parent graph, which is the one in blue, the vertex is 0, 0. But this plus 2 affected your x's and moved them which direction? Yeah, left 2 spaces, which means your x's are being affected. So is the x still going to be 0? No, the x is going to be negative 2. The y will still be 0 because nothing's affecting the y's here. With me? Okay. Remember, the domain is referring to x's, the range is referring to y's, isn't it? Okay, so now let's think about this. The domain is referring to our x's, and my domain is already from negative infinity to positive infinity. So if I shift this graph 2 spaces left, is it going to affect negative infinity to positive infinity? I mean, isn't it still going to open to negative infinity and positive infinity? Yeah, the domain really isn't affected because you're already using every real number in the world. Does that make sense? Okay, range. Now remember, the x's were affected. It moved left 2 spaces. So if the x's are affected, is the range, which is the y's, are they going to be affected? No. They're still going to start at 0 and end in infinity, right? Because this is the point, negative 2, 0. This is not going to be affected. Good? Okay, let's look at another example. Let's look at okay, so in this case, that minus 3, what is it affecting, your x or your y? Excellent. It moved into the house of x, didn't it? And since it moved into the house of x, this is affecting your x's. Now, we have to figure out which direction it's going, don't we? Which way is my graph now going to go that I put in a minus 3? Some of you may already know the answer, so hang in there. We're just going to verify it. Let me get rid of these x values from problem number 3, and let's look at x values for problem number 4. All right, the easiest one is 0. So the question is, what's the new x? What x can I plug in here that when I minus 3 gives me my original 0? If you said positive 3, excellent, because 3 minus 3 is 0, and I square the 0, I get 0. So if I take a look at just this one number, this 3, the value is to the right of 0, isn't it? So even though I minus 3, the graph is going right 3. Notice up here, we added 2, but we went left 2. Here I'm minusing 3, but we're going right 3. When it affects your x's, it goes in the opposite direction of the sign. This is a positive, I'm going in the negative direction. This is a negative, I'm going in the positive direction. Are you with me? Which means I can look at these and know that this is going to be a 4, because 4 minus 3 is 1, and 1 squared is 1, right? I can look at this and know it's going to be 5, because 5 minus 3 is 2, and 2 squared is 4, correct? Okay, so all of them are to the right, so that's going to be a 2, agreed? And that's going to be a 1, which means my whole graph picked up, and now it is over here. With me? Okay, so vertex, domain, range. Is my vertex still at 0, 0? No, the x's are affected, and my x went right 3 spaces, which means this x value on the vertex is now a positive 3. Is the domain really going to be affected? No, because it's already from negative infinity to positive infinity. You can't push it any further. And the range. Since this affected the x's, is the range going to change? Nope, it's still going to be from 0 to infinity. Does this make sense? Okay, so hang in there. I got a few more problems for us to work on. Okay, so I'm back. So we're going to look at these two problems here. Now, let's look at number 5. Notice I have got two numbers that are with this x, so to speak, on the same side as the x is the better way to put it. Now, we need to figure out what these numbers are affecting. Are they affecting x values or are they affecting y values? What are they affecting? So, do you notice this minus 1 moved into the house of x? How do you know? Because there are parentheses around the x and that minus 1, which means this minus 1 is affecting the x's. So, and this plus 2? Yeah, it's outside of that house of x, so to speak, which means this one's affecting the y's. Now, this minus 1, which direction is it affecting? Since it's affecting x's, is it going left or is it going right? Which direction is it going? Okay, some of you said it and some of you didn't say it correctly. You're like, well, how do I keep that straight? Remember the last two problems we did. Since this is a minus 1, what number do I have to plug into this x to make this parenthesis equal to a 0? Because that was one of the numbers we tackled on the table that we were using. Good, you plug in a positive 1, which means we're going right one space. 1 minus 1 is 0. And 0 squared is 0, correct? Now, this positive 2 at the end is affecting the y's. Good, which means it's going up 2 spaces. Now, let's double check and make sure that this makes sense, because I should get that positive 2. I should go up 2 spaces. Positive 1 plugged in, minus 1 is 0. 0 squared is 0. 0 plus 2 is positive 2, up 2 spaces. Now let's look at our vertex, domain, and range. The original vertex is 0, 0, correct? When nothing is added or subtracted to it, the original vertex is 0, 0, isn't it? But according to these two directions, you are moving from this 0, 0, which direction? You're moving right 1. And after you move right 1, yeah, you're going up 2. So your vertex isn't at 0, 0 anymore. It moved right 1 and up 2. Good? Domain. Yeah, the domain is always negative infinity to positive infinity. We've already spoken about that. And the range. The parent graph range starts at 0 and goes to infinity. Well, remember, the range is the y's. And according to your y's are moving up 2 spaces, which means your range starts at 2 and goes to infinity. You with me? Okay, let's look at this number 6 over here. Now, according to number 6, I have got two numbers that are on the same side as the x. I've got a positive 4 and a negative 5. Now, that positive 4 is affecting which variable? Good, it's affecting the x's. That minus 5 is affecting the y's because it's outside of the parentheses, right? It's outside the house of x. So this positive 4 is telling us that the graph is actually going which direction? Good, left 4 spaces, because negative 4 plus 4 is 0. 0 squared is 0. This minus 5, yep, down 5 spaces. 0 minus 5, minus 5. So the vertex was originally 0, 0, but now you went left 4 and down 5. So that's where the new vertex is going to be. Does your domain get affected? Nope, domain's not affected. Domain is still negative infinity to positive infinity. And the range. Now the original parent graph is at 0, starts at 0 and goes to infinity. But according to our information, your range doesn't start at 0, it starts at, good, it starts at negative 5 and goes to infinity. With me? Okay, so far so good, right? Now, I'd like you to notice something visually speaking. If I take a look at the graph of number 5, I know my vertex starts at 1, 2, and my range goes from 2 to infinity, so it's going up in this direction, isn't it? Now I got a question for you. Is this graph touching or even crossing this x-axis? No, it's not. So would you have any x-intercepts? No, you wouldn't. This graph has no x-intercepts. Because the vertex was at 1, 2, and it was going in the up direction, you're not crossing that x-axis at all. Now, let's look over here on number 6. You have a vertex at -4, -5, don't you? Right here. And it's going from -5 to infinity, isn't it, on your range? So, in this particular case, does your graph touch or even cross the x-axis? Yeah, it does. How many times? 2. This one's going to have 2 x-intercepts, whereas this one over here has no x-intercepts. So based upon where the vertex is and which direction it's going, in this case up, you're either going to have x-intercepts, or not have x-intercepts. Are you with me? Now, we are going to look at a function where a negative is in front of the x squared. And we're like, well, what is that going to do to my graphs? What's that going to do to the vertex, the domain, and the range? Think about it. Stay tuned. I'll be back to answer this. Okay, so I'm back to answer this question of what happens with the negative in front of the x squared. So here's the deal. First question I have is this. That negative actually represents what number? Good, because you don't see the number, so that negative actually represents a -1, doesn't it? So if you rewrite this, this is a -1, isn't it? And then you have the x squared, don't you? So what's the question? What's the operation between that -1 and that x squared? Good, it's multiplication. So did that -1 move into the house of x or not? Correct, it didn't. This -1 is not affecting your x's. This -1 is affecting your y values because it's outside the house of x. How do you know? Do you see any parentheses keeping the negative with the x? No, which means that -1 is affecting your y's, which means you're going to have new y values. So, look at this. We know that we plug in 2, we get 4, correct? Because exponents come before multiplication, don't they? So, 2 squared is 4, and then you do the multiplication. 4 times -1? Good, -4. Plug in 1, you square it first because that's first in the order of operations, which means you get 1, and then you get to multiply by -1, don't you? Which will give you -1. Yeah, 0 squared is 0 times anything is still 0, right? -1 plugged in is squared, gives you +1, times a -1 gives me -1, and that -2 will end up giving me a -4. So here's the thing, just like before, I have my original x's and now I have new y's. So you have a +2 and a -4, don't you? Well, +2 and -4 is going to be down there, right? +1 and -1 is going to be about there, isn't it? Still 0, 0. -1 and -1, and then -2 and -4. Looks like your graph is now doing this. Huh. So, what did this -1 do to my original graph? Yeah, it flipped it over, didn't it? Instead of going up, it's now going down, isn't it? So, let me get you the correct verbiage. This negative in front of the x squared tells you it reflected about the x-axis, which means the x-axis acted like a mirror and it saw its reflection in the mirror and now it's looking down. It's like you looking into a pool of water and seeing your reflection. Good? Okay. Now, let's talk about the vertex, the domain, and the range. Vertex, yep, still 0, 0, because it did not move left, did not move right, didn't move up, didn't move down. It was just a negative in front of the x squared, which told us it reflected about the x-axis. Got it? Domain. Yep, domain's not changing. Always negative infinity to positive infinity, even going down because it's still going out to the left and to the right. And the range. Remember, when you read the range, you read from the bottom to the top because you always go from the smallest numbers to the largest numbers. And when I look at this graph in pink, because that's my new graph, I'm noticing that it's going down, which means in this case, my range actually starts at negative infinity and it ends at 0. Y'all with me on this? So, be careful. That negative 1 in front of the x was not attached to the x. It was not moving into the house of x. It affected the y values instead. Got it? Okay, let's look at another one. Let's look at 2x squared. So, question for you. This 2, did it move into the house of x? No. How do you know it didn't? There's no parentheses around the 2 and the x, so it did not move into the house of x. This 2 is multiplied to the x squared, which means in this case, since there's no parentheses around it, this 2 is affecting the y values. Agreed. Which means I'm going to get new y values, aren't I? So let's take a look and see what our new y values are going to be. So I'm going to get rid of these guys. And let's take a look. Okay. So I plug in 2 and exponents come first, so 2 squared is 4. And then you do 4 times 2, which is 8. Yeah, order of operations, remember that. Plug in, take the 1, plug it in, you square it first and you get 1, and then you get to multiply by 2. Plug in 0, yep, square it first, gives you 0 times 2, still 0. Negative 1 squared, 1 times the 2, and I think you're getting the hang of it. Now, question. What happened to all my original y values? Yeah, they got multiplied by 2, didn't they? Right? Okay, so I think I'm going to have to draw the new graph over here so you can see it just a little bit better. So my original graph is here. Okay, there's 0, 0, 1, 1, negative 1, there's 2, there's the 4. Okay? But now I have 2, 8. So instead of here, I'm way up here. Instead of 1, 1, I'm at 1, 2. I'm still at 0, 0. But now I'm at negative 1, 2, and negative 2. So my new graph for number 8 here looks like this one in orange. What happened? Yeah, it looks like it got thinner, doesn't it? Okay, now we have to be careful, because if you say thinner or wider, isn't this an x direction? But this too affected the y's, so you can't say it got thinner or wider. You can't go in this direction. You have to go in the y direction. So it looks like I took the original graph, which is the one in blue, and it looks like I just yanked it straight up. So it became this new graph. We call this, since the 2 is there, this 2 stretched the graph. It became Gumby. It stretched it. Stretched by a factor of 2. You with me? Okay. I got one more of these. So let me get rid of this information right here. I know you have it copied down, or you can always go back and look at the video again, because we have something like number 8, but just a little bit different. So let's look at number 9. And the function I want to look at is f of x equals 1/2 x squared. Now, that 1/2, what is it affecting? Is it affecting your x's or is it affecting your y's? What is it affecting? Yeah, it's not moved in with parentheses, is it? That 1/2 doesn't have any parentheses keeping it and the x together, right? So this 1/2 is affecting your, yep, this is affecting the y's again. So I'm going to have new y values. So remember, exponents before multiplication. Take the 2, square it, you get 4, and then you get to multiply 4 times 1/2, which is 2. 1 squared, 1, times 1/2, 1/2. 0 squared, yep, 0, times 1/2, still 0. -1 squared we know is 1, multiplied by 1/2. And lastly, -2 squared we know is 4, but multiplied by the 1/2. So here's the deal. My original graph, right, was this one. We have 0, 0, 1, 1, -1, 1. We have the 2, 4, and -2, 4. Let's look at this new one. Now I'm at 2 and 2. Now I'm at 1 and 1/2. Still 0, 0. Now I'm at -1 and 1/2 and -2 and 2. Okay, my new graph is looking like this. Some of you may be saying, hey, that got wider. Remember, you can't say wider, you can't say narrower or thinner. You can't go in this direction when it's affecting a y. Because y's don't go left and right. Y's go up and down. So here's the deal. And I think some of you may have said the word already. This one looks like we took the graph in blue, the original graph, and we smushed it. And when we smushed it, it opened up, so to speak, even wider. And again, allow me the grace to say that word. So here's the deal. In this case, this 1/2 cut all my y values down, didn't it? It took all my y values and it basically divided every y value by 2, didn't it? Which means it compressed the graph by a factor of 2. Compressing it means you divided by 2. Stretching it means you multiplied by 2. Are you with me? Cool. Loving it. Okay, hang in there. Got a couple last problems for us. Okay, I'm back. So let's take a look at this problem. There's a lot going on here, and I need you to take a moment and identify what all this information is telling you. It is definitely a parabola because I see a square here, so there's no doubt about that. Question is, what do all these numbers tell me? So, order of operations says start with parentheses first, right? So I'm just going to look inside the parentheses, and I see this plus 4. What's it affecting? Yes, it's affecting your x, which means this graph is moving which direction? Good. Means it's moving left 4 spaces. Because remember, you have to plug in a -4 to make this parenthesis equal 0 again. Good. Now, what about this +1 at the end? Yes, that's your y value, which means not only is it going left 4, but in this case, it's going up 1 because it's positive. Good. Now, I've got 2 things happening in front of the parenthesis, don't I? I have a negative and I have a 3. So that's 2 different pieces of information. What does that negative tell you? What did it tell us before when the negative was out in front of that x squared? Yeah, that means it's going down. The negative means first it's affecting your y. Secondly, since it's a negative, it is reflected about the x-axis. That's what the negative sign means. This 3, yes, it's also affecting the y. Now here's the deal. It's being multiplied, correct? Which means, good, the 3 represents it is being stretched. The graph is being stretched by a factor of 3. So, I need you to think about this. I'm going to want the vertex, the domain, and the range. Vertex. Yes, this information tells me my vertex. My vertex says we're going left 4 and up 1. Correct? The domain. Yeah, the domain is still going to be negative infinity to positive infinity. That's not going to change. Now the range. You're like, what's affecting my range? Well, first off, this is affecting your range because it reflected about the x-axis. So is it still facing up? No, it's facing down. So now I have a graph that is starting at -4, 1, or the turn is at -4, 1, and it's being reflected about the x-axis, which means now it's going down. And yes, I just sketched the graph. I didn't put any numbers in, but I just wanted to see what's happening, so don't get too technical on me here. So if it's going down, where does my range start? Yeah, it starts down here. Your range is starting at negative infinity. And where is it ending? Yeah, it's ending at 1 here. Right? It's ending at the 1 value. Good? You with me? Okay. You have fun with this stuff. And oh, wait. One more question. How many x-intercepts do I have here? Good. You have 2 x-intercepts because the graph or the vertex starting in quadrant 2 going down tells me it crossed the x-axis twice. Got it? Okay. Now, you have fun with this stuff and I'll catch you on the flip side.